हेलो, कैसे हो आप सब लोग। तो आज हम लीड कोड की प्रॉब्लम ऑफ द डे सोल्व करने जा रहे हैं और ये सर्च इन रोटेटेड सॉर्टेड एरे लाइक हमें ना और देर इज़ एन इंटीजर एरे नाम सॉर्टेड इन असेंडिंग ऑर्डर विद डिस्टिंक्ट वैल्यूज, right? We are given with an array and it is sorted in ascending order. Prior to being passed to your function, nums is possibly left rotated at unknown index k, where k is greater than or equal to 1 and less than nums dot length, such that the resulting array is nums k plus 1 and so on till nums n minus 1, comma, nums 0, nums 1 until nums k minus 1. It's zero indexed. For example, 0 1 2 4 5 6 7 might be left rotated by 3 indices and we'll get our array as 4 5 6 7 0 1 2. Given the array nums, after the possible rotation and an integer target, return the index of the target if it is in nums or minus 1 if it is not in nums. You must write an algorithm with log and runtime complexity. Right? तो हम पहले ना like first I'll let you know what we are trying to do. It's problem number 33 and we are supposed to search in rotated sorted array. It's rotated sorted array, right? I think we first of all we are given with an array and that is already sorted. Let's say it's 1 0 1 2 3 4 5 6 7. If we are rotating it left by one time, then it will be the resulting array will look something like this: 2 3 4 5 6 1, right? This is my rotated array. Right now I'll be given with the target and we are supposed to search this number in this array, and we have to come with an algorithm that we are supposed to come with an algorithm that runs within time complexity big of log n, right? So it's basically binary search. Binary search is the algorithm that runs in big of log n time complexity, but the thing is it's not sorted. Binary search works on sorted array or either if it is monotonic array, right? So this array is my monotonic array, so we can run binary search on this array, right? The very first approach that comes to mind, few days back we solved the problem, right? Find the minimum element. We were supposed to find minimum in rotated sorted array, right? It was the problem of the day. You can watch my video, like I have already uploaded this. We were supposed to find the minimum in rotated sorted array, right? So if we know this problem, we can really solve this problem in very less time, right? So what I'm supposed to do, I'm supposed to find the minimum array. This is my minimum element in the array and its index is what? Its index is 5 0 1 2 3 4 5, right? So now I have partitioned, this is my transition point. I have partitioned my array in two array. Now it's also sorted, it's also sorted. Once I have find out my transition point, I can apply the binary search in this one and as well as this one. So it will take how much time complexity? 2 into big of log base 2n. Ideally it will be 3 because one time we are searching the transition. This is minimum in sorted array. The another one will be to search in the left half array which is already sorted, and to search in the right half. It's not half, it may be like any portion of the array. So once I am supposed to search in the left array and then right array, so it will be 3 into big of log base 2n. So it will be approximately big of log n. This works fine, but there are 3 iterations that we are doing for this array, right? I want this to be still improved. This is if we can do this in one iteration, having the time complexity of what? Big of log n, right? This is what I want to achieve. Now first let's take some example. So this is my array, right? So what is my transition point? This is my transition point, right? So I am first of all I'll find the minimum in rotated sorted array, right? So I'll get this index. This index will be my what? It will be 4, right? 0 1 2 3 4. So first of all I'll do 0 to 3 search target, right? And then 4 to last 6 find target, right? Once it is done, if it is returning -1, then I'm supposed to search in this. If it is also returning -1, return -1. Otherwise return the index where the target is present, right? Once it is in, let's take this one also. See, there are 3 examples, right? So paste it, right? So find the transition point, right? This is my transition point. Find the target in from 0 to 3, whether 3 is present in this array. No, so it will return -1. If it is -1, then I'll search in the right array. If it, what it will return? It will return -1, right? So finally my answer will be -1. In that case my target is 0, so it will return 4, right? And same goes for this array, right? So what is my transition array? It will be 0. So from 0 to -1 I'll search. From 0 to 0 I'll search. First I'll search in this array. It's already consumed, so it will return -1. And it will return -1 because from 0 to 0 we don't have the target 0, right? So if you guys need the solution for this, I'll first share the video and then I'll just paste the link for the solution, right? Or I'll show you in the end how I have solved this. But the second solution for this approach is way simpler. It's like within one iteration I have to find my solution, right? Is it possible? Yes, it is possible. First of all, I'll just plot my array over the graph, right? Let's say it will start from this number 0 1 2, right? Once it is done, right, it will look something like this: 3 4 and 5. From here onwards it will be 0 1 2. So my array will look something like 3 4 5 0 1 2, right? Now just take the whole array and find the midpoint, right? Midpoint. The intuition that we are using out here is what? It's way important. This line is very important, right? It's way important. You have to listen it very carefully. The intuition that we are using out here is what? The intuition is whenever we'll find the endpoint, whenever we'll find the midpoint, there is a surety. There is a surety of what? There is a surety that either my left array is sorted, If my left array is not sorted, then my right array will be sorted. How can I say so? Right, let's find the midpoint. Let's find my midpoint. 0 1 2 3 4 5. 0 plus 5 by 2, it will be 2. So this will be my left array, right? 3 4 5. So left array is sorted. This will be my right array. 5 0 1 2. It's not sorted, right? Midpoint, I'll consider midpoint in both the arrays, right? If 3 is less than 5, then it is sorted. If 5 is less than 2, then my right array is sorted, right? You can take whatever point you like. You can, if you are taking here, then my left array is sorted. If my point comes here, then my right array will be sorted, right? Because the midpoint is lesser than 3. So how can this whole portion be sorted? It's not sorted, right? Either this one will be sorted or this one will be sorted. So by using this intuition, we can find whether my target present in the sorted side or not. If it present in the sorted side, then I'll just reduce my state space to the sorted array. Otherwise I'll move to the state space with I'll move to the state space state space for with the array is not sorted, right? I think it's clear. Let's take some few example so that we can try run on this, right? So initially my L will be what? 0. My right will or high will be what? 0 1 2 3 4 5 6. 0 1 2 3 4 5 6, so it's 6. So while L less than or equal to R, right, find the midpoint. Midpoint will be what? L plus R minus L by 2, right? Now if I'll check this condition, will check whichever, either my left array is sorted, this thing is claiming, this thing is what I am claiming, right? Either my left array will be sorted or my right array will be sorted. First I'll check if my right array is sorted. If ARR of mid, right, is greater than or equal to ARR of low, right? If my left array is sorted, then I'll do this one, this thing. Otherwise I'll move to the else my right array will be sorted, right? Just by looking at this mere graph, we can tell wherever my midpoint is, either my left array will be sorted or my right array will be sorted. Even if it is in the midpoint, right? Even if it is on 5, then even if it is on 0, then my right array will be sorted, right? Till this point my left array will be sorted, till this point my right array will be sorted. If I know my left array is sorted, I can check if my element is present in the sorted array or not, right? If target is greater than or equal to, it means what? If array mid is greater, my left array is sorted, left array is sorted, that means from low to mid it's sorted, right? If target is greater than or equal to ARR of low, and first check if element is present at midpoint or not. If ARR of mid equal to what? Equal target, then we can directly return what? Return the midpoint, right? So if target is greater than or equal to ARR of low and target is less than what? Target is less than ARR of mid, right? It won't be equal to mid because we have already checked this condition out here. So it will be less than. If it present in what? Left array, then do what? High or right, whichever. Right, we have taken the right equal to what? Mid minus 1, because I want my binary search to search in the state space in which the element is present, right? Otherwise move it to the sorted array. Else do what? It's sorted array, right? Move it to reduce the state space to sorted array. Otherwise move it to what? L equal to mid plus 1, right? Now else, we'll see the else situation. Now my right array is sorted, right array is sorted, right? Now I'll check if my array present, if my target present in the right sorted array, right? So if target is greater than or equal to what? Greater than ARR of mid, right? And what will be my right array is end? It will be if target is less than or equal to what? ARR of what? R, right? Because my left array will be from my low to mid, right? Right array will be from mid to right, right? I'll do what? I'll increase my L equal to mid plus 1, right? Otherwise do what? Else R equal to mid minus 1, right? If it is not, if it doesn't present in the sorted array, then I'll do what? I'll reduce my state space to left side, right? And once my else condition is checked, I'll close my while loop while there is scope of some element, while L is less than or equal to R is indicating that we are still present with the state space. Once it is done, and if somehow we have come out of the loop, then I'll return what? Minus 1, right? So just every time we are reducing it to half, right, in each of the case. So my time complexity will be what? Big of log base to n, right? That's it. So I'll start implementing the solution. And so so int L equal to 0, right? This is my left side. R equal to what? R equal to nums dot length minus 1, right? While L less than or equal to R, right? Int mid equal to what? L plus R minus L by 2. Why I have done L plus R minus L by 2? It's simply L plus R by 2, but to avoid the integer overflow, we are just using this formula. Now check if the left side of the mid is sorted, right? We are with one intuition that either the left array will be sorted or either the right array will be sorted. Why? Because this is how my graph is going to look like, right? There may be a case when both the sides are sorted, but I'll just fall back to any of the cases, right? It will be my case, right? Now if I have midpoint here, it is also sorted. If it is sorted, I can take decision on this basis. Either it will present here or it will be present here, because if I have sorted array, I can easily see if it presents in here or not. Otherwise I'll move it to the other direction, right? So it will work both for both the edges cases. This will be the case when there will be zero rotation, right? So check if the left side. How can I check if my left side is rotated? If ARR of mid is, if middle element is greater than or equal to what? ARR of low, then my left array is sorted. Otherwise my right array will be sorted, right? Now the thing is, because we have sorted array, left array is sorted. Now if it present in the, because I can easily find out if it is present in sorted array or not. If it present in the sorted array, reduce the state space to that corresponding state space, right? If target is greater than or equal to ARR of low and my target is less than or equal to what? My target is less than or equal to what? My target is less than ARR of mid, right? That means it present in the sorted space, and sorted space it present in the sorted state space. This time I'll reduce my sorted space to what? Make your R to what? Mid minus 1. Otherwise make your low to mid plus 1, right? Once it is done, right, now my right array will be sorted. Now do what? If target is greater than ARR of mid, if it present in the right state space, and then target is less than or equal to what? ARR of R, then do what? Make the state space to what? L equal to mid plus 1. Otherwise do what? Else R equal to mid minus 1. Once this is done, once my whole state space is reduced, and if somehow I comes out of the loop, then I'll return minus 1, right? Let me run this. Oh, if it's not ARR, let's do it ARR. Then what? That's all. Sorry. It's not low, bro. It's L. What else to error we saw? ARR of low. Expected. Oh. Let's see. Oh, now it's failing. Let's see why it's failing. I think for each time it's returning minus 1. Right? Can anybody debug why? R L plus R minus L by 2. If ARR of mid is greater than L, right, then that means my left array is sorted. If target is greater than or equal to ARR of L and then target is less than mid, then R equal to what? Mid minus 1. Now we have skipped one of the important condition, that is, if at any of the moment, if ARR of mid equal what? Target, then return what? Return mid, right? This is the condition we have like skipped. So let's submit this. And what is my space time complexity for this? It's big of 1, right? What about time complexity? It's big of log base 2n, right? So these are my time complexity, right? So let's reduce that you can see the whole. So this is my whole code, so that you can see it once. So this is my whole code, right? Now if you remember, I have discussed the very first solution in which we'll find the minimum transition point, and then we'll find the my target in both the arrays. So I'll show you the solution for that as well. Solutions, let's see this one, not this one. So this is my solution. Let's like first I'll find the transition point. It's very similar to the one we have solved the other day. It's transition point. So I'll find first I'll do this. This is how you can see the video for this in the other video. Like once we have find the transition point, I'll find in left array. Just give 0, point -1 and your target. Simple binary search a number using binary search. If left is not equal to -1, return left. Otherwise search in the right space and return that value. That's all, right? Let's reduce the size so you can see the whole code, right? Let's copy this code. So this is my whole code. Right. So that's all from my side. Thank you very much. And if you have any doubt, just let me know. Feel free to comment. I'll try to resolve that doubt. Thank you very much. Bye bye. Take care.